It's chemistry and you are watching Damn Science.
In this video, we will see that for A-level chemistry practicals, how to solve the qualitative analysis questions. We will see some virtual readings, or we can say we will see some virtual observations about the questions and what points to take care about such writing the observations. So let's go ahead with one of the example of a qualitative analysis question from one of the past paper of A-level chemistry practical questions. Now here, these are the important points we should take care, and so let's go ahead first about these important points, that when the reagents are selected to use in a test, the name of the correct formula of the element or compound must be given. So in that case, we need to either write the name or the correct formula of the reagent we are using. Then at each stage we need to note down the color changes seen or the formation of any precipitates, and when the precipitates are formed, the important part is write its solubility in the excess of the reagent given, even if it is not mentioned in the question. So this part is very important. Its solubility should be mentioned in the excess of the reagent. If some gas is formed and if it is suitable, identify the gas and write the test. And also we should clearly write that at what stage of the test the change, that is the color change or precipitation, has occurred. And during the test, if any solution is warming should be done in the boiling tube and not the test tube. So this has to be taken care, that whenever there is a warming, we need to use boiling tubes and not the test tubes directly. We can always rinse and reuse the test tubes or the boiling tubes provided to us during the practicals for any of the tests we are going ahead in this question. Now before going ahead with the question, let me show you that these are the last pages of the question paper where the reactions of the aqueous cations, that is the test of the cations, are given properly with full reagents. You can see that the reagents used are NaOH and ammonia in the aqueous form, that is the solution form, and their observations are given along with the name of cations. So this we will be using. Then the reactions of anions, that is the test of the anions, are given with what solution, what reagent is used and what is the observation. Along with that, the test of gases are also given. Now here we need to understand that suppose if any of the gas is produced or vapors are produced, we need to understand that we need to test any of the gas produced here with the test given. So by default, even if it's not written in the question, if we think that there are some fumes or gas bubbles or some vapors produced, accordingly kindly use this gas test and find out which gas is produced. So now let's go ahead with the question. So here is our question 3 of one of the past paper, which says that Fa6, now this is the reagent which is given to the candidates. This Fa6 contains one cation and one anion, both of which are listed in the qualitative analysis notes. So the notes which we have already seen just now. From that list, one of the cation and one of the anion is present. Now what is the test which we are supposed to do? Heat Fa6 gently for 1 minute in a hard glass test tube in which it is supplied, and then heat strongly until no further change occurs. So here now we need to understand that first gentle heating is needed in a hard glass test tube or the boiling tube in which it is provided, and then later on there is a strong heating. Now we need to write the observation of both the gentle heating and strong heating. So here we can see that it carries 2 marks. So record all your observations. Now if a test is given in 2 stages, here in the first question itself the 2 tests are given, that is gentle heating and strong heating. So I'll just tell you that on gentle heating there was no particular observation, but we can see minute fumes. Now if the colorless are fumes, so we can just write that colorless gas produced. So this is the observation which we will write, colorless gas produced. Now if this is a colorless gas, if we know that the colorless gas might be ammonia or might be some other gas like hydrogen and carbon dioxide will produce bubbles. But let's go ahead, say this colorless gas is tested in different ways. I'll give you the observation here because it's a virtual reading. So colorless gas is produced. Now this colorless gas turns damp red litmus paper blue. So I'll write that colorless gas produced turns damp red litmus paper blue. Now we need to understand, just check that red litmus paper blue. So I'm just writing it here, and then we need to understand that if this is the gas, we need to check it with the damp red litmus paper or check it for carbon dioxide or hydrogen. And if it turns red litmus paper blue, then this gas is an ammonia gas. But here we are not supposed to write about it. We just need to write the observations only. So this is our observation. What about now strong heating? So that is our second point. Even if we don't write it in bullet points, but we need to understand, write it differently. So on strong heating, it produces white fumes, or we can also say that in some of the cases, some of the candidates might observe that in place of white fumes, white solid deposits on the top of the tube. So white solid deposit on the top of the tube, So this is what we are going to write our observation in two parts. Now identify the ion that must be present in Fa6. Now this clearly, the first test itself clearly tells us that it is ammonia. So one of the ion is NH4 plus. So either we can write ammonium ion present or we can write it in the form of the formula. Both is acceptable. So the A part of this question is done. Now let's go ahead with the B part of the question. Now with the B part of the question, here we are two different reagents are given, Fa7 and Fa8. Aqueous solutions are given. Each solutions contain one cation and one anion, both of which are listed in the qualitative analysis notes. So again, the list which is given in the notes, from that itself one cation and one anion is present in each of the solutions of Fa7 and Fa8. Now use 1 cm depth of Fa7 and Fa8 in the test tubes of the following test. Now this is not necessary to be exact 1 cm. You can approximately take the 1 cm depth of Fa7 and Fa8 in the test tubes and perform the test. So let's go ahead with the first test. It says add a few drops of aqueous potassium manganate, then add a few drops of starch indicator to Fa7. Now here we can say that the Fa8 is made gray in color. That shows that we are not supposed to perform this test. Now here is in Fa7. On adding potassium manganate, I'll just give you the observations that yellow-brown color of the solution was observed. So yellow-brown color. Now I'm not writing just the color. I'll write yellow-brown color solution because I didn't get the yellow-brown color precipitate. It was a clear solution. There was no precipitates, no solid particles. So I need to write it yellow-brown color solution. Now solution is important. Now in the same as we can see that there are dotted lines here in between. That shows that the next test should be continued in the same solution. So after getting the observation of yellow-brown color, in the same solution add few drops of starch indicator. Now here the observation is the solution turned blue-black. So blue-black solution. Now here in this the color is so dark that even if you write blue-black solution or blue-black precipitates, anything is acceptable. So this is the first observation and first test. Now the next test, FA2, with the test 2, FA7 and FA8. Now here we are supposed to write observations for both FA7 and FA8, and here also we can see that there are dotted line in between two of the tests. So again, the test 2 is divided into two parts, which we have to perform it all together but turn wise. So add a few drops of aqueous silver nitrate and then add aqueous ammonia. Now for this I'll say that again, refer the note and find out that on adding aqueous silver nitrate, which is the test which needs the reagent silver nitrate as a test, and then aqueous ammonia. So let's go ahead and check our notes. Here we can see that the cation is having the reagent aqueous ammonia and aqueous sodium hydroxide. So this is not what we are performing. So next you can check the reactions of anion. Now check here. Can we see anything with the silver nitrate? Yes, here we can see that we had used silver ions for the test. Now if we are adding silver nitrate, this is the test we are performing. Out of the list of all these anions, you can check further also. Is there any other test with silver? Yes, these are the 3 tests. So you need to understand that now we are performing the test of either chloride, bromide or iodide ions. Okay, now the next part of the same test was add aqueous ammonia. So now we are checking, you can see here we are checking the solubility of ammonia of this one of the anions precipitates solubility in aqueous ammonia. This is what we are checking. So now let's go ahead with the test 2 here. Add few drops of aqueous silver nitrate. Then, so on adding aqueous silver nitrate, we had observed that there were yellow precipitates. We won't say that it would be very dark yellow precipitates, but then we can't call it as off-white or white. So it was yellow precipitate. Now it says add aqueous ammonia. So in this yellow precipitate itself, add aqueous ammonia. But then we knew that if we add excess of aqueous ammonia, the precipitates remains insoluble. So we can just write insoluble, that is the precipitates remains insoluble. Now if we are performing the same test with the FA8, the observations which we got is white precipitates. White precipitates are observed. So this white precipitates, again we have to test the solubility of this white precipitates with aqueous ammonia, and here we observe that the precipitates dissolve. So we need to write the precipitates dissolve. Precipitates dissolve. So this is how we are going to write the observations in 2 different rows with proper writing. So solubility we have to write here in the next partial column, and the first observation has to be written in the top row. So now let's go ahead with the test 3. Test 3 says add aqueous sodium hydroxide, then pour the mixture into boiling tube, warm gently and carefully, and then add a piece of aluminium foil. Okay, so this test is divided into 3 different parts, but it has to be performed turn-wise with both FA7 and FA8. Now as we have already seen that adding NaOH is generally a test of the cation. So here we are looking for a cation. So when aqueous NaOH sodium hydroxide is added to FA7, we observed no change, no precipitate. So we can write here no change, or we can write no observations, or we can say no color change. Anything can be written. Now in the same no change solution on adding sodium hydroxide, now the same mixture is heated gently. Now this heating has to be done in the boiling tube. Now as we are doing the warming, let's understand that if a gas is produced, has to be tested. But here no clear bubbles were seen, but we can say that some fumes were observed. So these fumes turned red litmus paper blue. So turned red litmus paper blue. That we have to write. Turned red litmus paper blue. So this is the observation we'll write for the next part of the test on heating the mixture of NaOH and Fa7. And in the same warm solution, add a piece of aluminium foil. Now here again there was no observation, so you can write no observation or no change. Now the same test has to be done with Fa8 also. So again we are adding sodium hydroxide with Fa8 solution in a test tube. So when sodium hydroxide is added to Fa8, white precipitates is observed. White precipitate has to be written. Now if the test is some change or some observation is there, especially precipitates, then we need to check its solubility by default. So to check the solubility, we are adding excess of NaOH. So we need to write here, so its solubility in excess reagent, that is excess of NaOH, it was observed that the precipitates are insoluble. So just write insoluble in excess reagent, or we can just write insoluble, that is also acceptable, insoluble in excess reagent. And in the next stage for this, it was observed that there was no change on adding aluminum, so write just no change. This is how the test 3 is performed. Now let's go ahead. What is for the test 4? On adding test 4, it says that add a few drops of dilute sulfuric acid to both Fa7 and Fa8. So when dilute sulfuric acid is added to Fa7, there was no change observed. So you can say that the solution remained unchanged, solution remained colorless, or we can write no change, no observation, anything can be written, it's acceptable. But with Fa8, it was observed that the white precipitates were formed. White precipitates, this time I'm writing in short, but here you can write it in full words. Okay, here there are only few drops of dilute sulfuric acid is added. Now here we don't need to check the solubility, because that solubility has to be checked either with NaOH, that is sodium hydroxide, or ammonia. Dilute sulfuric acid won't make any change, but still if we want to check, we can add few more drops of dilute sulfuric acid, as it's mentioned here, just few drops of dilute sulfuric acid. For the test was not mentioned, but still if we want to check, we can check, and we had observed that there is no change, no precipitate dissolving. So this is a complete table. You can see that we have completed full table. Now from here we need to make the conclusion. So here let's check some of the reagents here. Yellow precipitates with silver nitrate and white precipitates here observed with silver nitrate with Fa8. Now as we had seen that with silver nitrate, let's go ahead with the anion test. With silver nitrate, there were 3 anions possible, which says here it gives white precipitates which is soluble in ammonia. Then iodide is insoluble, which gives yellow precipitates. So here these are the 2 observations we got. We didn't get cream precipitates or of white precipitates. So here we knew that Fa7 had iodide and Fa8 had chloride. So these are the 2 anions which we have already found out. And now what about cation? With NaOH, what observation had we obtained? With NaOH and Fa7, let's check the observations again. With NaOH, that is sodium hydroxide, and we had observed that there is no change, but on gentle heating the gas turned red litmus paper blue. So we need to check the cation for this, and then white precipitates which were insoluble in excess reagent for Fa8. So let's go ahead with the NaOH. Here we got white precipitates with Fa8. Now white precipitates here is there for the aluminium, but it is soluble in excess with NaOH. Now ammonia we didn't perform, so we didn't need to check for that. Now with ammonium ion, it says no precipitates, but ammonia gas is produced on heating. Now that we have already seen that there was a colorless gas which turned red litmus paper to blue. So the cation may be NH4OH for Fa7. Now this was the observation for Fa7. Fa8, white precipitates were produced but it was insoluble, so aluminium is not present. Next, white precipitates are here. Faint white precipitates always observed unless reagents appear. So faint white precipitates, yes, we had observed white precipitates. Next, calcium can also be there, which is white precipitate, but it says that it's only present when there is a high concentration of calcium ions. Now, which we don't know whether it's a high concentration or not, but we just knew that we had taken only 1 centimeter depth of the reagent, so high concentration is not possible. So here we are left with only this chance where Ba2 plus should be present in Fa8. Fa7 we have observed that there was no precipitates but ammonia gas was produced. So Fa7 we knew it's NH4 plus. Now Fa8 there are chances that Ba2 plus, that is barium ion, is present in Fa8 according to our observations. Let's check the whole table. Is there any other white precipitates observed? Yes, with zinc again there are white precipitates, but again they should be soluble in excess, but our precipitates were insoluble. So again the zinc ions not possible. With manganese it's off-white precipitates which turns brown. So again we don't have that observation. So the only possibility left is barium ions. So now we have got both the cations and anions for Fa7 and Fa8. So which we can write here. So deduce the chemical formulae of Fa7 and Fa8. Now chemical formulae, that shows that we are not allowed to write the names. Fa7 we knew that it is ammonium ion, so NH4, and iodide ions were detected with yellow precipitates of silver nitrate with silver nitrate, so it is ammonium iodide. Fa8 had barium, so barium should be written, and it was chloride, so we write chloride, but the formula is BaCl2. Now we need to understand that as barium was present, barium gives the barium sulfate white precipitates with sulfuric acid. So this is how we can make out, confirm. Yes, we should know that the barium ions will produce white precipitates with sulfate ions. So here is the confirmation test that it was not calcium, it was barium which is giving the barium sulfate white precipitates here. So this was the confirmation test of barium. This also should be observed. If we have some confusion, there must be some other test given which will confirm our anion or cation. Okay, next there is one more sub question left for the same question. It says give the ionic equation for the reaction of Fa8 with sulfuric acid. Now we are talking about this test. Now we, as I just said, barium sulfate precipitates are produced. So the ionic equation says barium ions. Now it says that include the state symbol. So the barium ions were taken in the aqueous form. So we write barium ions aqueous form. It reacts with the sulfate ions of the sulfuric acid. So SO4 minus in the aqueous form. It is going to produce barium sulfate which is precipitated. So write solid. So this is how you're going to write the ionic equation. So this is how you write the observation. So what are the points to be taken care of? First, write all the observations. If the solution is clear, don't write just the color, write solution, and don't write see-through color or don't write any other. You need to write colorless solution if there is no observation. Don't write such words as see-through or transparent. Write colorless if there is no change or the solution is colorless. If it's just a color, no precipitates, then write solution. That is how which we have written in our first observation, yellow brown color solution. That is important. So that also we need to write if we get precipitates for any of the test. Definitely we need to check their solubility with excess of reagent, especially with aqueous NaOH or ammonia. That is necessary. If of some fumes or gases produced during the test, Need to test which gas is there. So there are gaseous tests given at the qualitative analysis notes. We need to go through it and check for the gas produced. So these are the important points we need to take care while performing the qualitative analysis question in A levels chemistry paper.